Write down question. ABCD is a parallelogram. A, B, C, D. ABCD is a parallelogram. Okay. And E is the midpoint of AD. E is the midpoint of AD. This is the midpoint here. E is the midpoint of AD. Full stop. A line through D drawn parallel to EB. Now EB is joined, and a line is drawn parallel to this line, that is EB. This and this line are parallel. So it meets here. When you extend this here, it meets here somewhere at point F. Got it? This point is taken as L, right? So a line drawn through D drawn parallel to EB meets AB produced at F and BC at L. It meets BC at L and AB produced at F. So this point here is F and this point is L, right? Prove that. First point you have to prove here, AF is equal to 2 times DC, and second part you have to prove is DF is equal to 2 times DL. DF is equal to 2 times DL. Okay, these two things you have to prove. A question is clear? Take out your fair notebooks. You should be having, all of you should be having your fair notebooks. Write down this question which I've given, and we'll do the proof of this question. So I repeat the question in figure. ABCD is a parallelogram. E is the midpoint of AD. A line through D drawn parallel to EB meets AB produced at F and BC at L. Prove that number 1, AF is equal to 2 times DC and DF is equal to 2 times DA. So what is AF here? This is A and this is what? F. AF is equal to 2 times DC, 2 times DC, 2 times of this, and DF is equal to, DF is this, D is this, and F is this. DF is equal to 2 times of 2 times of DE, 2 times of DL, 2 times of DL. That is DL is this. Okay. Now, yes, yes. Want to say anything? Okay. Now see here. It is given that this is the midpoint right over here, right? So this side you see, this is the midpoint. So this line is what? Parallel to this first point. DE is parallel to which line? BL. Why? Because this is a parallelogram, so opposite sides are parallel, right? Because AD is parallel to BC. Opposite sides of parallelogram are parallel. Second point you see, second point you see, point number 2. EB is parallel to DL. Why? Given, this is given to us that this line is parallel to this is given, and this is equals, this is parallel to this also. Third one you see, therefore DEBL is a parallelogram, isn't it? Therefore EBLD is a parallelogram. Reason is opposite sides are parallel. Okay. Fourth point you see. Now you see in triangle DLC, D is this, L is this, C is this triangle. Got it? And FBL, FBL, these two triangles you see, these two triangles, right? First of all, you see CL is equal to BL. CL is equal to BL. Why? BL is equal to BL is equal to what? It is the parallelogram. This is a parallelogram. So this side is equal to this side, and this is equal to half of what? This side is equal to half of this AD. So this is equal to half of AD. So this is also what? This is half of AD. So this means this is also half of AD. Not clear. This side is equal to this side. So this means this is equal to half of AD. So if this is half of AD, the remaining is this, because opposite sides are equal. Got it? Huh? Clear na? So you see here, BL is equal to what? BL is equal to what? ED. Opposite sides of parallelogram are equal. And ED is equal to what? Half of AD. And that is equal to what? Half of AD is equal to AC. So half of AC. This means what? BL is equal to half of AC. This is equal to half of AC. So this is half of AC. This means this is also what remaining is there. So this is the whole is equal. So you see what? That CL is equal to one. This is what? CL. So you can say simply you can say that BL is equal to CL. Is that okay? Now here you see in triangle DCL and triangle BLF. Okay. Now you see first point here. These are vertically opposite angles. This side is equal to this side, right? And you already know here that alternate angles. You see, this and this are alternate angles, no? But this line both are parallel. So this angle and this angle will be alternate angles. Got it or not? Hmm? So you see A part here, first part you can say, this CL is equal to BL proved above. Second part, angle DLC is equal to angle BLF, vertically opposite angle. And C part you see, angle DCL is equal to angle LBF is LBF, alternating angles. Therefore, you see triangle DCL, triangle DCL is congruent triangle FBL. The reason will be yes, angle right, right area. Okay, okay now. Therefore, what conclusion do you get? That DC is equal to what? DC is equal to BL CPCT, है ना? CPCT. So this side and this side both are equal. This point is clear. Now, and DL is equal to what? DL is equal to DL is equal to what? DL is equal to, check. DL is equal to FL. Right now? This is also by CPCT. Okay. Now if both of them are equal, then you see BE is equal to DC is equal to BE is equal to DC is equal to BE is equal to DC is equal to AB. Okay. DC is where? Where's DC? This is DC. Okay. So DC is this, and DC is equal to what? Wait. DC is equal to BF. Okay, that we have done. This is BF. DC is equal to BF. DC is equal to BF. Okay, and is equal to what? AB. Right? Is it okay? So this, and this all are equal. Clear? So you can simply say that twice of AB is equal to twice of DC. And twice of AB means what? Twice of AB is equal to twice of DC. Is it okay? And so you see now, twice of AB means what? AF twice DC. So this implies DC is equal to what? AF is equal to 2DC. So first part has been proved. This is your first part. Now you see second part. Huh? DL is equal to what? DL is equal to FL. So you can simply say that DL is equal to FL. No? So twice of DL, same way. You can say what? DL is equal to FL. So this implies that DF is equal to twice of DL. Twice of DL. DF is equal to, what is this? DF. DF is this. From here to here, this is DF. And DF is equal to, DL is equal to FL. DL is equal to FL. So that is DF is equal to, DF is equal to twice of, twice of DL. This is twice of DL. And hence you see, this is second part. DF is equal to twice of DL. This is the second part. This is proved. First and second part both has been proved. Clear? Okay. Just see it properly. I'll send you the screenshot shot of it. Next question, write down. PQ and RS are two equal PQ and RS are two equal and parallel line segments. PQ and RS are two equal and parallel line segments. Full stop. Any point M, any point M not lying on PQ, any point M not lying on PQ, any point M not lying on PQ or RS is joined to Q and S. and lines through P parallel to QM and lines through P parallel to QM and through R parallel to SM and through R parallel to SM meet at N full stop, meet at N full stop. Prove that line segments MN and PQ, prove that line segments MN and PQ are equal and parallel to each other. Prove that line segments MN and PQ are equal and parallel to each other. I repeat the question. PQ and RS are two equal and parallel line segments. Full stop. Any point M not lying on PQ and RS is joined to Q and S, and lines through P parallel to QM and through R parallel to SM meet at N. Prove that line segments MN and PQ are equal. Line segments MN and PQ are equal and parallel to each other. Are equal and parallel to each other. Okay. Now let's see here solution for this. What does the question say? First thing, PQ and RS are two equal and parallel line segments. Okay. So you see one is line is PQ and another is RS. So PQ and RS are two equal and parallel line segments. This is PQ, RS. These are equal also and parallel also. Right? Now, if they are equal and parallel, so if I join them, what I will get? What a parallelogram, very good. Because in a quadrilateral, if one pair of opposite side are equal and parallel, then it is a parallelogram. Any point M not lying on PQ, any point M not lying on PQ. So there is a point here, which is M, which is not lying on PQ. Any point M not lying on PQ or RS, neither it is lying on PQ, neither it is lying on RS, is joined to Q. This is a point here, M, which is neither lying on PQ nor lying on RS. Neither it is lying on this PQ nor it is lying on RS. It is here, right? So any point M not lying on PQ or RS is joined to Q and S. This is joined to Q and S. This is joined to Q. This is joined to S. M is joined to Q and S. Okay, Q and S. And lines through P parallel to QM and lines through P parallel to QM through QM and through R parallel to SM meet at N. So here this is a line here which is drawn parallel to this, and this is a line is drawn here which is parallel to this. Both of them are meeting at this point at N. Got it? N. Prove that line segments MN and PQ. MN is this. MN and PQ. PQ is this. MN and PQ are equal, okay, and parallel to each other. MN and PQ are parallel to each other. This is equal to this, and this is also parallel to this. Question is clear now? So there's a line PQ, there's a line RS, both are equal, both are parallel. Now there's a point M, which is neither lying on this line nor on this line. Here it is. You join this and you join this. Through this line, you draw a line parallel to P. Through this line, you draw parallel to this and join them. You have to prove that MN is parallel to PQ and MN is equal to PQ. I think question is clear now. How to prove this? So here, as I told you that this side and this side both are equal. This side is parallel to this, so both of them are. So it forms a parallelogram. So first point you see is PQRS is a parallelogram. PQSR. PQSR is a parallelogram. Got it? So this is a parallelogram. Now here you see the question says that this line is drawn parallel to this. This line is drawn parallel to this, and this line is drawn parallel to this. Okay. So what you get here? You get here. Suppose you extend this here, and make this angle as 1, this angle is 2, this angle is 3, this angle is 4. Okay, right? So angle 1 is equal to angle 3. Why? Because these two are parallel lines intersected by a transversal, so these are corresponding angles. So angle 1 is equal to angle 3. Yes or no? Angle 2 is equal to angle 4 because these are corresponding angles. Any doubts? Okay, then you can extend this also. You can make this angle as 5 and this as 6. Okay, now, right? Now you see angle 2 is equal to what? Angle 4, because this is a line here. This line and this line both are parallel, so these are also corresponding angles. So you can simply say 1 plus 2 is equal to 3 plus 4. Angle 1 plus angle 2 is equal to angle 3 plus angle 4. This point is clear? Huh? So what do you see? Angle P and R is equal to angle QM, QMS, correct? Angle QMS. QMX. This is okay now? Any doubts? Now you again see angle PRS is equal to angle QS. You can take this as X. QSX, right? So angle again you see angle PRS is equal to angle QSX because these are also corresponding angles. Is it okay? Is it okay? Now you see this angle and this angle are also equal. 5 is equal to 6. This angle are corresponding angles. Nah? So from this angle PRS, if you subtract angle 6 is equal to angle 5. You write like this. So if you subtract now, so what do you get? Angle PRS minus angle 6 is equal to angle QSX minus angle 5. This point is okay, right? So you get angle huh? PRN is equal to which angle? QFN. So you see this angle was equal to this angle. Got it? And you see this angle is equal to this angle in these two triangles, right? And see this side is equal to this side. This side is equal to this side, na? Because opposite sides of parallelogram are equal. So you conclude that this triangle is congruent to this one. Got it? Therefore, therefore you can see triangle PNR is congruent to triangle QMS. Okay? And if they are congruent, so you see PN is equal to QM, PN is equal to QM, and RN is equal to SM. Got it now? Huh? This side is equal to this side, and this side is equal to this side. And this side is parallel to this, and this is also parallel to this. So this means this is a parallelogram, and this is also a parallelogram. This is a parallelogram, and this is also a parallelogram. Both of them are parallelograms. Yes or no? Huh. If they are parallelogram, then PQ is equal to NM, right? PQ is equal to what? PQ is equal to MN, है ना? MN, NM, whatever you want to write. PQ is equal to NM, and PQ is parallel to NM. Hence proof. Is it clear now? Okay.